So
and then we are going to have a coupling being 30 by 90, and the outrigger's location at these 2 stories, and this is the flat setting point, this is the phrasing. So let's get to the parametric study. Yeah, go ahead.
So just to confirm, coupling beam is the shear walls
Yes.
in the interior.
Between the 2 shear walls, the 2 cores.
The outrigger is the large beam that we have that's,
Yeah, that has the story height level.
and then the spinner beam is on the outside between the walls.
Exactly.
Okay.
That's it. Yeah. So right now we build a base model. So let's see how we can do the parametric study. Once we build a base model, you are gonna, for example, try the next parametric study. So you are gonna save your model as and build another model. We are gonna do few changes to the base model. You are gonna select all the beams that has dimension 30 by 100, and they are called spandrel beam, and assign a new beam that has dimensions 30 by 60. Okay, and our base model is the same. So we have a base model and we are changing one parameter at a time. Okay, so we are not gonna change all the parameters and like all at a time. So we have a base model, 30 by 100, having all these dimensions, and we are gonna change one parameter. What is it? You save the model as and select all the beams that has 30 by 100 and assign 360. Okay, and then you save your model, and then I mean like save as and make another model and select all the beams that has 3 by 100 and assign 30 by 80, and save as a model and 30 by 120, 30 by 140. Okay, but when I'm saying base model, not only the geometry, we are gonna assign the loads, assign everything, so that we don't need to redo the work. Like we just adjusting one parameter. Like, because if we didn't assign the loads and we make save as and we build, for example, 30 model, you need for each one of these 30 models assign loads. Okay, so we assign the loads one time and do everything one time, and by just like 1 minute of your time, you will go to your model, select something and change it and save it. Okay, so we did this, and that. Same thing here. For example, we are going to test how the coupling beams is affecting the building performance. Okay, so how we are going to do this? So the base model has a coupling beam 30 by 90 dimensions. So the width is 30 and the depth is 90. So what we are going to do, we are going to fix the 30 and see how 30 by 50 is going to impact the model, 30 by 70, 30 by 90, 30 by 110. Okay, and every one of them, you are going to change the model. Okay, so you will tell me, all right, so I have 30 by 50. So which one of these I'm going to use? Because I have many parameters. You are going to use the base model, 30 by 100. Okay, so our fixed model is 30, 100, 30, 90. And we're only changing one parameter at a time. All right. At the end, what we are going to do, we are going to show some graphs, X and Y, how the beam widths, the coupling beam widths affecting the building drift. Definitely, if I increase the width, it's gonna make the drift less. Okay, and it's gonna affect the shear lag, for example. How the coupling, how the spandrel beam depth is affecting the shear lag. Also, at the end, you guys are gonna share your results with each other. How? For example, we need to study the impact of the column spacing on the building drift. But each one of you has different spacing. So for example, group 1 got the drift of the building 0.7 meter. But group 2 got 0.8, group 3 got 0.9, group 4 got 0.1 meter. So you will share your drift with each other, and then you will plot how the columns' spacing impact the building drift or impact, for example, the shear lag. All right. So this is, for example, how you can read the dimensions. I'm gonna send this again, and I make these two red as these so that you can know that this is the base model. All right, and we are gonna change one parameter at a time. So we'll keep the base and only changing the depths. Keep the base model and only changing the widths. Keep the base model and only changing the depth. All right, so this is an example on how the parametric study is gonna have. So let's see how many models you guys are gonna have. You are gonna have the one base and extra 4, so this is 5, and another 3, so you're gonna have
4
8,
by 4, 16.
and then another 4, so yeah, let's say 5, and then 3 is 8, and then another 3 is around 11 models. Okay, right?
I think it's 20. Oh, that's 5 by 4.
It's 5 what?
5 by 4.
No, we are gonna make it like we are gonna fix one thing. Like you are not gonna test these different 5s with these different 4.
Okay.
So you are gonna have 3 by 100 and test this 4. Like you are not gonna see how 3 by 60 impact this 4 or 3 by 80 impact this 4. But it's only 3 by 100 and see how. So you have only one base model. Okay. All right. So I believe that's it for now. So let's see how we can build this model from scratch. Let's see how's the project look like. All right, so as we talked last time, this is how our cube is gonna look like. The building is 60 by 60 meter, but 60 by 60 meter is not fixed. You can make it 62, 63, depends on the spacing, okay? For example, I was trying to make 3-meter distance, so I made it 30 to 63, okay? For example, you are gonna have 2.5. And 2.5, for example, if you multiply it by 25 or maybe 27, you might end up with having like 27 spacing. So you can find this distance is gonna be, for example, 64.5. That's fine, okay? So we just need equal spacing between the columns and the distance makes sense, like 3, as you are assigned at 2.5, 3, 3.5, 4. So it's fine, like if you have this a little bit bigger or not. And the internal spans should be around, for example, from 6 to 10 or 11. Why I'm saying this? Because usually we don't want to make this span very big, because if you make it very big, the slab thickness is going to be much bigger because there will be large deflection. Okay, so I'm giving you the slab thickness of 30 centimeter so that we can maintain spans around 8 and 9 meter. Okay, if you make it much bigger, like 11 meter, we definitely need to increase the slab thickness, maybe 35 or 40, so that we can don't have big deflections. Try as much as you can to have these columns in line with this shear wall. If you didn't, it's fine. Like if you didn't to have these columns in line with this one, with this shear wall, that's fine. Like the example that I have here. Like here, I could have done what? I could have made this much closer here and decrease the length of the coupling beam between the shear wall. All right, so this is one thing that we should do. Building the model on ETABS. If you want to build the model from scratch on ETABS, like did you guys know how we did the grids? You identify the grids, how many grids in X, how many grids in Y, and you keep drawing the columns one by one. But this will be very tedious. Why? Because at least each side has around 20 columns. So we are talking about you are drawing 100 column or maybe 150 by your hand. But if you were able to export the model that I gave to you and send it to ETABS and do it the way that I showed to you last time, it will be much easier. If you guys remember how we draw these models on ETABS, we need to export the columns as a bully line, like closed, not single lines. Like, can you see this rectangle? All these lines need to be connected together. If it's a regular line, like broken lines, ETABS is not gonna see them. But if they are bully line it means like it's connected, ETABS is gonna see them, okay? So this is one thing. And make sure they are not blocked. Like if you make a AutoCAD block, ETABS is not gonna see them. That's one thing. Drawing walls is the same thing. If you want to export this wall to ETABS, you need to have this wall on a bully line, like lines connected, and ETABS is gonna see them. Beams, you need to draw a line in the middle of the beam that connects the shear wall. So you need to draw a line from here to here and a line from here to here so that the ETAPs can see that. Same thing here. Here, what we are gonna do, like if we want to draw this spandrel beam, we usually, when we model this beam needs to be connected from the center line of the columns to all the center line of the columns. It is not as it's shown here. Why? Because as we said in finite elements, it needs to be connected at joints. Because when we draw a column, the column is a line and the beam is a line. So they need to be, and the lines are in the center line of the element. So at the center line of the column, I'll make a line and connect all these columns by a line. And when I go to ETAPS, I assign a frame element on this line. Slab, if you want to draw a slab, you'll make a rectangle area from here all around here, and we assign a slab. So let's see how we can convert this and make it ready to go to ETAPS. So I made it to save time, but I'm gonna show you how it looks like. All right, so look at this. Can you see this green line? So this green line, I made a line that connected between. All right, so let's move this. This is the slab. So can you see this purple line? This one. This one is the beam, and it's not connected because the beam can be broken, like because it's a frame element. So I made a beam that connected the center line between all the columns, and I can assign it a beam in ETAPS. And the slab was on top of the beam. I just moved it so that you can see the layer down. So let me do Control Z. And the slab is the green line, and the slab, because it's an area, so it needs to be connected lines. So if I click on this, it's gonna be a rectangle. Same thing with the columns, like so that ETAPS can see the columns. I need to click on this, like this line, and it needs to be one connected area. But if you draw it like this, line like this, ETAPS is not gonna assign column to this because this is a broken line. It needs to be one connected line like this for all the columns. And the next is the shear wall. So for the shear wall, if I click on this area, it's all one connected lines. So I will be able to draw them on ETAPS. What I did here, I did also rectangle area because I have a void in this location. Like if you look at this plan, because there's elevator here, I have a void. So I created a rectangle area, and I'm gonna assign void at this area. Here, I didn't draw the line of the beam, and I'm gonna tell you in a few minutes why I didn't do it. And once you are done, like, because I'm gonna send you this file, so you need to do the same thing like what I did. You need to draw a line in the middle of on the columns so that you can draw the beam. You make sure that the columns are all joined. And same thing, you draw a slab element. For the slab, actually, you can draw it in ETAPS. It's very easy. Like, but the columns, it's a lot of element. And same thing here. I made sure that this is one connected line. And once you are done and prepare your model, you make save as. So save as. And then you make sure it's a DXF. And you can name it maybe October 18 DXF. And then let's save it. All right, so once I save this, I need to close the file on AutoCAD. If you didn't close it, ETAPS is not going to read it. It will tell you it's in use in another software. So let's close what we have done, and let's get to ETAPS. Did you guys start to have ETAPS on your machines? Did any of you try to have ETAPS? All right, just one thing to keep in mind, we are using the trial version, which is good enough for 1 month. So it's gonna expire. If you download it today, it's gonna expire on November 18th. So to make sure that you have the valid license until the end of the semester, like until the end of December. So not all the groups should have download ETABS maybe on their machines, like maybe two or one in the group download it, the one who is gonna handle the modeling. And once the license is gonna expire, the other one can download it and work, and you keep working on the other machine so that we can manage having a valid license until the end of the semester. Unless you will be able to finish the project in 1 month. Okay. All right, so let's continue trial. So actually my license is going to expire in 20 days. So last year we were fortunate to have a license, but this year we didn't. Anyway. So I'm going to say file, new model, as we learned it before. And here I'm going to make the units metric because we are using meters. And I'm going to say, okay. All right. So we are going to have a 60-story building. So I'm going to change this to 60 and make sure that the height is 3 meters. And I'm going to start with a blank model, like, because I'm not going to draw grids. I'm going to import the AutoCAD file. So I'm going to make it blank and then say, okay. All right. So let's make sure that my units are consistent. So I'm going to make it meter and ton forts. Okay. So let's import the AutoCAD file that I just created, import, and here there are many things that you can import from. There's like, for example, you can import DXF file of architecture grids, like you can import grids only, you can import floor plan. We are going to use this one, DXF DWG file of our architecture plan. Okay, so let's import this one. And I just created this one, the October 18th version. And okay, so when this window open, just make sure that the units are good, because I draw an AutoCAD in meter, not in millimeter. So my 63 meter dimension, if I said okay, is going to be 63 millimeter. So I need to make sure that this is meter. And if I import it, it's going to be in story number 60, but I need to start with story number 1. So I want to have my layout in a story number 1, and the units are meter. Here's going to ask you some questions. For example, if the AutoCAD file that we have is not at 0 and 0, like for example, it's at 60 and 60, and we want to move it, so you can move from 60 and 60, with negative 60 and negative 60, so it can't be moved. And you can scale it if you want, you can do rotation, but this is not what we are gonna do. So I just gonna change this to meter, and I change this to story number 1. And let's say okay. All right. So right now I can see the 3D view of the layout, but I can't see here the model that I just imported. Do you guys know why? Because I'm in story number 60. So I need to go in a story number 1 so that I can see my model. So I imported the layout, and as you can see, I can't see the hatches of the columns. Why? Because it was blocked. Mostly when you draw hatch on AutoCAD, it puts a bunch of lines in a block, and you cannot, if you import it to ETABS, you cannot see them. All right, so next step is you have 2 options. The first one is, what is this line? Because I don't have it in AutoCAD. Interesting. Let's get back to the AutoCAD file. Open was 18th. I didn't have a line here. Anyway. Okay, so you have 2 options now. You can define, you start first at all by defining the materials, the concrete, the steel, define the sections, all the sections that you have, the spandrel beam dimension, like we said that the spandrel beam is going to be 30 by 100. So you define the beam, define the slabs, define the walls, define every cross section. And when you start to work on this, every section that you assign, you already define. Or you can start by random section and let ETABS do it for you, and then you go check if these sections are right or wrong. Okay, so for example, if I want to do it, like let's go back to AutoCAD and see what sections that we have. Let me double check on the columns dimensions. So distance from here to here. So I have 1 meter, and I believe by 1 meter. So I can go to ETABS and go define, make sure that the material I have concrete and steel, I'm gonna use them. But I need you to do a little bit search. We are gonna use, I need you to do a little bit search on concrete materials for tall buildings and see what is the industry is using for concrete slab, which is regular concrete strength. And for columns, we are gonna use high strength concrete. And you can choose whatever. I know that there is some high strength concrete that it can be goes up until 100 megapascal. So usually the concrete strength for a slab is around 30 megapascal, but you can go up to 60 in columns. Okay, so why? Because this is going to help with the stiffness of the building if the material is much more stiffer. All right, so let's go to define materials. I'm done. I said we are going to use the regular one. Let's go to sections. All right, I'm going to define a concrete beam for the spandrel beam. And as we said, it's going to be a spandrel. Let's say SP, spandrel beam. Width is 30 by 100 centimeter. And then I make sure that the depth is 1 and the width is 0.3. And the material is concrete. All right, and I hit OK. Concrete columns, we have 1 meter by 1 meter, so I add a copy of this. And I'm gonna say column 100 by 100 centimeter. And I make sure that this is 1 and this is 1. And OK, I define the columns, I define the beams. And let's get back to, oh, all right. So maybe if you want, you can define all the cross sections that you have in this model. Like you can define the 30 by 100, 30 by 90, 30 by 70, all the cross section one model, because when you save it as, and you take the another model, so every section is defined. So all what you have to do is to assign the new section. Like here, as you can see, you can define 30 by 60, 30 by 80. We already did the 30 by 100, 30 by 20, 30 by 40. Define all of these and keep them in your model. And when you save it as, you can take it back and then assign the new sections. All right, so the next part, what I'm gonna do is defining the shear walls or the slab. Okay, let's go with the slab section. Slab 1, I will add a copy of it. So I'm gonna make it slab 30 centimeter. And I made sure that this is 0.3. And okay, I need to check the walls. What is the dimension of the wall that I have here? So distance. The wall I have here is 0.7. So let me get back to ETABS and define sections, wall sections, and I add a copy of this property and I make a wall 0.7 centimeter. Oh, sorry, let's make it 70 centimeter. This is a name, it's gonna have a huge difference, but definitely we needed to make it right so that we can memorize what wall that we have here, because if we are cutting the wall section as we're going up, and this is not what we are gonna do, we have like a constant cross section for the entire building. So we can keep it wall 70 centimeter. So we have 0.7. All right. So I'm done with this. The next part, if 0.7, actually it's very, very small. I can see what I read. Right. Okay, so we have 70 centimeter wall. All right, so for the columns, as we said here, we will have different dimensions in the columns for the different stories. So at the definition of the column, you need to save as the cross section and keep it changing. 100 by 100, 95 by 95, until you go to the 75 by 75. So you need to define 6 cross sections for each 10 stories. Okay, I did only 100. All right. So I think we are ready to assign the sections. So yeah, go ahead. And match the column because it's a vertical element. So columns and shear walls is vertical elements carry lateral load and carry vertical load. So they will be high strength concrete as well. It's a good question. All right. So the next step is that we need to assign the sections that we have done. As we did before, we can go to draw and we can draw the sections, but we are not going to do this because AutoCAD file is going to help us. Okay, so let's see how we are going to draw the columns, all the columns. Maybe we have 100 or 100, maybe 200 columns, draw them one at a time. So you will go to display, models, plan view, and you open the layers that you have here. This is the AutoCAD layers that we have, and all the columns are drawn in this layer, columns. We are gonna right click on this layer, and you will have some options. It will ask you, do you want to draw an area object, wall object, column object, or beam object? All right. If you draw an area object, what is going to happen? It's going to draw a slab, a small slab in this area. Okay, and that's what we don't want that. We want a column object. So ETAPS is going to read the dimensions that we have here and assign the column that we defined 1 meter by 1 meter to this cross section. If it matches the dimensions here, like let's say that we defined a column 1.2 by 1.2, but when he reads this dimension, he found out that this is 1 meter by 1 meter. He will neglect the cross section that you developed, and it's gonna develop its own cross section. So let's see if it's gonna happen or not. All right, so let's add a column object. All right. It's gonna take a little bit of time, maybe it takes 5 minutes, it depends. So what I did, I spent 1 hour before the lecture preparing, like after what, like here, when this is done, like it's loading the column, we will get back to it. Once it's done, it's gonna show up something like this. So it's gonna assign a column at each one of these, like the one that you see here. So at each one is gonna make a column. If you click on this, you will find the cross section that you already defined. And also it's gonna add a boundary condition. It's gonna make hinges. But for this tall building, hinges is not a good boundary condition because usually tall building is built on a very stiff foundation. You have piles and pile caps. So fixation is the right boundary condition that we should use here. So if we want to change this boundary condition, let me see. This one is still loading. And this one also has problem loading. All right. There's the name of this folder. More plan.
All right, so actually the model that we started, it built the columns before the other one loading. Okay, so right now we have the columns ready. So right now the model that we were running has the column. Let's check if this model assigned the columns that we defined. So let's go zoom in a little bit here. The model is a little bit heavy because it has lots of column. So let me click on this column, right click. Can you see what columns that has been assigned? The one that we defined, column 100 by 100 centimeter. All right, let me zoom back. And if you want to show the 3D view of this, I mean like to make the columns a 3D, you can click on this, like you click here, and then you click on this one. This one is going to show you an extruded view of the columns, how they look like. And if you want to change the boundary condition, you will go down to the story number 0 and click on all of these and assign, joint, restrain, and make all of these fixed. Okay, so right now we are done with the columns. So let's do the next thing, the walls. Let's see if the walls is going to be written right or not, because I can see a line here that might mess it up. But let's see. For the walls, let me check what layer that we draw the walls at. Let me click on this. The walls at a layer is called columns and walls. Get back here and go to this layer, right click and add wall object. So the wall object should be a little bit faster than the columns because we have just 2 of them. Actually, this one looks like it's there's no model here. Let me close this one. All right, so the walls is done. So let me click on this wall and see what cross section that is assigned to this wall. Can you see the wall 70 centimeter? If we didn't define it, it's fine. What is the ETABS is gonna develop the section, but it's gonna say wall 1. And then you can modify it. You can go check the dimension, change the name, change the material, do whatever you want. Okay. Maybe some people found it easier. Why should I put dimensions? Well, ETABS is going to define the dimension for me and I'm going to edit them. So maybe this is an easy way to do it. So right now I have the walls. So what is next? I have columns, I have walls. Let's do the beams first, okay? We do the beams and then do the slabs. Okay, so let's go see. I believe the beams is here. Let me check on ETA on here in this model. I just need to move this slab layer. Actually, I can turn off this slab layer. And this one is at layers called beams. Okay, so let me get back to ETABS and get back here and go to beams. And then I'm going to add a beam object. So when you add a beam object on this beam, it's not going to take the beam. Let's see, it's going to take the beam that I defined or not. Right, let me click on this. No, it didn't take the beam that I defined. So what I'm going to do, it put a non-section. Non-section is a dummy element that doesn't have any stiffness. So you can select the 4 beams lines that we have, or you can do select properties, frame section, and you select the non-section. So if you select them, it's going to show you down there that we have 4 frames that are none. And then you're going to assign the beam section that we just frame section properties, and then we define the spandrel beam 30 by 100, and then we will say okay. Okay, so right now, since it was before it was none, it didn't show any beams here, but let's see how we can show it right now. Let me click on this one and see, because sometimes it needs some loading. All right. So if you have a view that doesn't show something, you can cancel it from the X and then add it again. Like you can do add new window. And let me make this extruded view. I can see the beam here. Okay, let me check this box and see extruded view for the frames. apply, and now I can see the beam. So right now I have the columns, I have the beam, but as you can see, the beam here has very small dimension, like 30 centimeter. Is that gonna be good for the tube?
No, it's not gonna be good for the tube. Usually, if you want the tube is gonna work good, if you have a very stiff column and less stiff beam, sometimes the column doesn't feel the beam because it's not stiff enough to make the tube action. So usually, if you want this tube action to be perfect, at least this beam needs to be half the column dimension or more. Like if this column is 100, so the width of the beam needs to be at least 10 to be strong enough to take much more internal forces from the column.
Okay, so we have the columns, we have the shear walls, we have the beams. So let's get to what is next. Let's get to the slab. So we draw the slab system. I believe we just turned off this layer here, which is slab E-tabs. And I will get here to slab E-tabs. And I'm gonna add an area object. So we have an area object here. Let's click on it and see what section that we have here. We have slab one. So actually you can change it from here. You can click on this one and it change it to the slab 30 centimeter that we have. And then you will say, okay. Or you can go assign slab section. So both of them are the same thing. Let's check on this one. We have a small slab here. It's called a slab one. We are gonna make it as a void. We have wall. You can make it none, or you can go to assign shell and opening. And then you'll say, okay. Well, sign shell opening. I don't know why it didn't work. Okay, yeah, it works now. And then the same thing here. You can select them both at the same time, assign shell opening, and just make sure that this is an opening. All right, so we have two opening here. We have everything. It doesn't load here right now, but it's fine. So we have the verse the story. Do we miss anything? We draw almost everything. Slabs, columns, decoupling beam. This is the rest one. But we draw everything.
Except we have this shear walls, it's not connected together. All right, for the coupling beam, you'll think about, okay, how about I draw a frame element with the coupling beam that you already told me about? And this frame element is gonna connect this wall with this wall. If you draw a frame element connecting two shear walls, this shear walls is not gonna feel this element very well. Because if you want to, because the coupling beam has a specific reinforcement that make these two walls connected together. So we usually draw the coupling beam between the shear walls as a shell element.
Can you turn on the slide? Thank you. So, as we said last time, this is my shear wall. And it's a very big element, not a frame. If you put a frame element, just the line connected this joint with this joint is not gonna be stiff enough that this is gonna feel it. So what we do, we make a shell element with the depth of the beam and with the length of the beam that connect this two beam at each story, something like this. That's how we model coupling beam. And as we talked last time, if this is one shear wall, like this, doesn't have any openings, like this is opening, like this, and you have a load here and make a moment like this, the stress curve is gonna be tension here, compression here, and the stress strain is gonna be something like this. This is how the moment is gonna have, like you will have a force here and a force here, and this is how the moment look like. We want, if we were able to make this shape here, that makes that we make this the coupled shear walls acting with 100% efficiency, but it's impossible.
to have this efficiency. But how it's gonna be like if it's 100% efficient? It's gonna be something like this, and this, and it's a line, but it's gonna be. This is how the shear wall is gonna look like. If you were able to reach to the maximum efficiency. Why? Because you made all this shear wall have tension and all this shear wall have compression. And how can we get this? By making this coupling beam very, very stiff enough to make this two shear wall acting as a one shear wall. But in real life application, this can be something, for example, like this. Like it's not fully tension, so maybe it can be something like this. Or this one is going to be something like this. Has some tension, some compression. As soon as we make this go a little bit down, that means that we are increasing the efficiency. How? By increasing the stiffness of this beam. If these two beams angle as if these two walls acting as a single walls, they are going to be something like this. This wall is going to have tension compression, and this wall is going to have tension compression. Something like this, all right? If they are acting as a separate walls. But if we get them to this one, that means it's the perfect fitting. So how we can do it, let me show you. Can you turn off the light? All right, so let's do it. Let me get closer here so that you can see what we are gonna do. And let me get closer here. All right, so I'm gonna go to draw a wall. So when we draw this beam, we are draw it as a wall, but I'm gonna show you how we are gonna change it. I will go to draw wall, and when you go to draw wall, okay, I need to click here so that I can draw the wall. If you go to 3D, if the 3D is active, this is gonna be deactivated. You need to be here and click on wall. So if you go to wall, it's gonna ask you what type of area that you are gonna draw. If it's a wall, it's called veer. But if it's a beam, you will find the spandrel is gonna show up. So you will go to spandrel. This one. And when you turn the spandrel, it's gonna ask you about some dimensions. What is the depth above the center line? What is the depth below the center line? So since we said the spandrel is gonna be 100 for now, and the width, I believe it's gonna be the same width of the wall. Like we can choose the width of the wall. Like we have wall 70 centimeter. So we are gonna choose the wall dimension, and we are gonna make the depth below one meter. And let's draw. I will draw from here to here. And I will make right click and I draw one from here to here. Did you see it? This is the spandrel beam. I draw it here. And it's 1 meter below the center line, not above the center line. And it has the same thickness of the wall because we use the same cross section. All right, so I believe our model is ready. And if you want to show the thickness, so you can go here and show extrude shell view, and you can see all of them are 3D, something like this. All right, so I'm done with the story number 1. Let's see how we can do this for all the stories. I'm gonna view this view set 3D. I'm gonna make these angles 0. Sorry, I'll make this 0. And what I'm gonna do, I'm gonna select this, except
without selecting the boundary conditions. Why? Because if you select the boundary conditions, it's going to be added to all the stories. Like there is a foundation at each story. The foundation is only at the base. And then I'm going to make replicate. And I'm going to replicate this story from story 1. I mean, like, it's already in story 1, but I'm going to replicate it until story number 11. So I'm going to put it in 2, 3, 4, up to 11. And I'm going to say, okay. Why I did this? Because you have a different cross section starting from story 11. So what you are going to do, you are going to select all the columns in this story like this. Sorry. I select all the columns, and here is going to show that you have 116 frame in this story. Okay. And then you will go to assign frame section and go to section properties, and you will need to define the other section, like the column 90 by 90, and then the column 80 by 80. And then once you are done, you replicate until the story number 21, and then take the story number 21, change the cross section, and then replicate to story number 31 and change the cross section of the column. And if the wall is a changing cross section, you will changing the cross section of the wall as well. So what I'm going to do right now, I'm going to make Control Z just to make the model faster. And I'm going to take this and replicate it for the 60 story. From story number 60, let's go here and then say, okay. All right, so I have right now the 60 story, but you will have to change the columns. Let me tell you a trick that you can do. You can go to the grids here, add and modify grids. And you go to story grids, like quick add a story or set story names. So you can modify and show story data from here. Something that we usually do with tall buildings, we usually group the stories with a master story. Like if we know that we have 10 stories are similar, like story from 2 to 10 are similar to 1, we make one as a master story, and all the others is going to be similar to it. So anything that you change to story 1, loads, cross sections, columns, adding beams, is going to be changed in the other similar stories. So this is something that you can do it. How? You can go here and go all the way down to story number 1, and you can make it as a master story. You will find master story, you say yes, and this one are no, so you make them similar to story number 1. So you make from 1 to 10, all of them are similar to story number 1, and you do the same thing with the story number 11. You make a story number 11 master story. So I come here and make 11 as a master story, yes, and then you make story number 12 similar to story number 11. So we have a story number 1, 11, 21, 31, 41, 51 master stories, and all the other stories are similar to it. Just in case, if you miss adding loads, if you miss doing anything, you do that, okay? But my advice to you right now, like before you replicate the stories, you need to assign all the loads, all the vertical loads, because right now I replicated 30 stories, but I didn't assign loads. So I need to assign them one by one, or I assign to the master stories, okay? But if I did the loads, I already have the on weight in the bed, but I can add the live. You will use the same live load that we given in the homework, 1.92 kilonewton per meter squared, and maybe flooring 1.5 kilonewton per meter square. So this is the same loads that we are gonna use. This is gonna be much better rather than assigning it to 5 master stories. Okay, is that everything good right now? All right, so let's say that we assigned the loads, we did everything, and and did the master stories, and say, okay, let me show you how to draw an outrigger. So for example, group number 1 has an outrigger in story number 15. So I go to ETABS, story number 15, I come here and let me click on plan, and in plan, I will go to story number 15 and I hit OK. All right, in story number 15, first, I need to delete the beams on the perimeter. Delete. Let me select all the beams on the perimeter. This one, and this one. So I selected 3 frames. I'm gonna tell you why did I deleted these beams. And maybe you can delete these shear walls, or we can keep them. Let's keep them. Just the beams. All right, so let me go define wall section. And I'm gonna define a wall that is add a copy, and I'm gonna say outrigger OR, and let's make the section 70 centimeter, like the wall, make it 0.7. And then I'm gonna say okay. So let's draw a wall in here. So we are gonna draw the belt around the building from this column. And also I believe we need to delete the columns as well. So let's, all right. So this is one thing that I want to tell you about. We made the master story, right? So when you do something here, you need to make sure that you want to do it in all the similar stories or not. So if I'm doing something here and I have this as a one story, that means is I'm only changing in this story. But let me, okay, so can you see this drop panel? Okay, so anything that I change here, if this is one story, is only make the change in this story. But if you have similar stories, so anything that you change here is gonna be changed to similar stories. Okay, and if you activate all the stories, so anything that you draw here is gonna be drawn in all the stories. Okay, so if I kept all the stories here and I draw an outrigger around this building, so it's gonna make an outrigger in all the stories, and your building is gonna be a box of shear walls. Okay, so we need to do everything that we are doing here is just in this story. So what I'm gonna do, I'm gonna make a wall around here, and I need to delete all these columns so that I can draw this wall. So let me select these walls, these columns, sorry, in this story. Can you see it only select the columns in this story? And I'm gonna delete them. All right, so we don't have columns in this story. And what I'm gonna do, I'm gonna draw a wall that has the section of the outrigger, OR 70 centimeter, and I'm gonna draw a wall from here to here. Here. All right. So right now I have a belt around the building. All the columns from the up is gonna like rest on this wall and then transfer the loads to the other columns. Okay, so right now I draw the belt. So let's draw the outrigger. So the outrigger itself is gonna be a wall that connect the outer side here with this shear wall here. Okay, and same thing. And it's better. All right, let me do this. Let me select this one, delete. But I'm gonna delete the shear walls and the spandrel beam here. Delete. And this one is gonna be one continuous beam with the story height. All right, so I'm gonna have something Control Z. Right. Let me keep them so that I can be guided when I draw the wall. So let me draw from here to here, and then I'm gonna draw them when I'm done. I'm gonna delete them. So right now we have overlap at the location of the core. And then I'm gonna draw something like this. They are connected, like they are connected at this joint. It's like a divided area, but you can make them as one line. So I was saying that if you can connect these columns with the outrigger, like if you can keep them on this line, that will be much better. But usually the farthest the columns, the much better for the moment. Like if these columns are in the center of the outrigger, they are useless because they are at the point the stress are zero. So the stresses are much bigger at the ends. So mostly is the columns on the outer perimeter is the one that takes most of the tension and the compression. Okay. So right now I want to delete these because I don't want to have double cross sections at these locations. So let me delete these. And right now I have an outrigger at this location. Let me show you how it should be look like in the 3D. Let me make the 3D. So this is how the outrigger look like. Oh, so you guys tell me what is the problem that I have here now. So what did I do wrong that makes the outrigger look like this and not the story height?
I think when we post the standard way.
Yeah,
We can-
when we draw it, we the last draw that the last wall that we draw was a spandrel, not a beer. So it takes it from the last one that we draw. So let's fix this. So what I'm gonna do, I'm gonna select all the select and properties and then frame section. And I'm gonna select the outrigger, not frame section, it's a wall section. Select wall section, and then I have an outrigger. Select, and I'm gonna assign. We can assign the wall section, or let's assign the wall section because it's the same section as the outrigger. Shell, wall, and then let's assign wall 70 centimeter. They have the same cross section, so it takes the story height. It didn't. Okay, so let's. All right, it's. Okay, so let's go to the plan, story number 15. Okay, let me control Z. It's outrigger. I have a better idea. We can select properties, wall section, outrigger. Select, let's find a way that we can fix what we did and make it as a sign, shell. I think there's a spandrel. Not this one. I'm not sure if there's a way to fix it, but let me do this. Let me click on this one. And if I go here, geometry. Or any spandrel OR. No, none. I can see anyway. Which one? Can you see? I can see sphere.
Big one. Where?
Yeah.
But it says none. It should be.
Span. Okay, let me make this beer. Oh, this is a beer label. No, it's not gonna work. Okay, let me do this. Let me select properties, and then let's go to walls, outrigger, select, and let me delete them so that we can. Okay, let me make sure this time that I don't have them as a spandrel. I was drawing in 2D, so I didn't see. So let's put it here as a beer. So once we draw them as a beer, they are gonna be at with the same story height. Right. And I can draw one here. One here. Then you can make one here. So just make sure that you draw it right. I mean, like, you can make a grid here so that you make sure that you hit the right location. And once you are done, since you have two outriggers, you can replicate this outrigger to the next story. Like you can select the outrigger sections that you draw. For example, right now I draw the outrigger and let me show in a 3D. So okay, so right now the outriggers looks fine here at this story. And if you want to replicate it to a different story, you select the properties, area section, wall, and then outrigger, and then select, close, and let's see where's the other one in story number 45. So you will go to edit, replicate, story, and then you select the story number 45, and then you hit OK. So once you do this, make sure that you don't have overlapping sections, wall inside a wall. So right now you got all the outrigger. Yeah, but can you see here? What we have here is columns inside walls, okay? So you need to delete the columns, delete the wall sections so you don't have an overlap, but this will help you to save you some time redrawing again, okay? So right now we have the outriggers. If you want to draw bracing for the groups that has 4, so basically you are going to create a bracing element, like for example, the same cross section of the column, 100 by 100, or a steel cross section, okay? And you are going to open the 3D view, and then you keep connecting the columns one by one, drawing the bracing column by column, like from here to here to here to here, until you get back to the other end. And then once you get back to the other end, you go all the way up in this direction, and you make it from the other side. So you draw elements like this until they connect and keep doing them like this, story by story. Like basically you will have 2D like XZ view, and you keep drawing an element here, element here. Once you draw them, you will draw one line of the bracing. You do it from the other side, they are going to be connected together. So you will do it for this side and this side for the 4 sides. So that you have all the building is braced. So this is how you build the geometry. So your task right now is to start working on building the geometry for your project. Okay, and don't forget to put the loads. I'm gonna send them an announcement and tell you what is exactly the gravity loads that you are gonna use, the dead, the live, and the flooring. It will be basically like the homework, like 1.92 for live load, 1.5 kilonewton for flooring, and it will be that's it for the gravity load. Then we will have another lecture tell you a little bit background about seismic loads and then how to assign them to your model. Okay, All right, so that's it for now and see you guys next week.